Howdy folks, I'm Keith Bowen. This is Hard Rock University and another lab edition here. Now, this whole smelting process and everything entails something called parting and inquarting. Now this bead here is almost pure gold, okay? But when we first smelt something, we'll get a bead that looks more like these here. And as you can tell, those aren't nearly as yellow. The way you would turn that into pure gold is dissolve the silver and any other metals in there, but there's a problem. If you have too much gold, like this is pretty yellow here. So that's probably running 70–80% gold. That is so much gold that the nitric acid can't do anything more than just etch the surface. Pretty quickly gets blinded off. This, on the other hand, has more silver. If you have enough silver, then nitric acid can dissolve everything except the gold and leave you a little pile of gold particles laying around. Okay? That process, when applied in assaying, is called parting, where you take the nitric acid and use it to part the silver from the gold. The problem with that is you have to have enough silver. So in many cases, like in our case, we're getting majority gold. That's not enough. You need at least 3 or 4 parts silver to 1 part gold in order to make the parting successful. So in order to do that, you will often have to add a known amount of silver. And here we have powdered silver. This has been recovered. Is this ours or is this
No.
Tripp's?
Ours is back there.
Okay, so this is from Prospector Tripp. He's been doing some silver refining. And that's actually finely ground silver. Well,
Let me open the bottle so you can see.
okay, go ahead. It doesn't look too silver, it looks more white, but that's more of an optical illusion than anything else. Under magnification, it looks pretty silver. So we will estimate how much gold we expect to get from a smelt and put 2 or 3 parts silver to every part gold that we estimate, and then we'll get a silver looking bead that we can then part. Now the problem, well not the problem, but one of the issues with this situation is when you part the silver, it goes into solution, and what do? Throw it away? Well, that's not good. So we'll do what Prospector Tripp did here. He dissolved like silverware and things like that in nitric acid and then precipitated the silver, and we're going to do the same thing from our parting acid. We're going to neutralize it and then recover the silver from it. This is Eva, and we're precipitating some silver from our nitric acid, probably not on the countertop with nitric acid, little one.
You neutralized it.
I know, but it's usually better to have some kind of a catch container. Okay. So anyhow, what we have here is presumably copper nitrate now. That is precipitated silver from the silver nitrate. The way they usually do it when refining is they just keep adding silver till it no longer dissolves. Because of our requirements, we can't really do it that way. And make sure you don't put so much in there that it doesn't overfill either one of those, this or that. You can put more than that in there. What I'm saying is that you want to make sure that you don't put too much in there.
I understand that there.
Okay. So anyhow, it's usually best to get the clear stuff first, because as soon as you start getting sludge into that filter, things slow down dramatically. Whatever that sediment is, which theoretically is silver.
Oh, it's silver. It's shiny.
It settles down real fast.
It is shiny.
Anyhow, so we're gonna pour this solution through the filter and then rinse the silver. You see the silver in there. And then we'll dry it and we'll be able to reuse it.
If you look at it from the top, you can see it's shiny.
Yeah, well that's fine. You also got some solution on your finger there, so be careful where you put your finger. Alrighty, we'll get back to you when we're rinsing. And here's the silver we precipitated out of the solution using copper. Or you could say we cemented it. Either one is fairly accurate. And now we're going to dump it in here. Let it drain and then rinse. Little one, you want to wash that out of there, please? Gotta let it drain, take a little while. We're likely to play some games with that copper nitrate there too. We could either cement it with iron or electroplate. We'll probably try electroplating just for jollies, as we're getting a little more experience with our electroplating equipment here. So there is theoretically cemented silver. Now we just got to dry that out. I'm kind of rinsing it still. It's getting pretty, the rinse water's getting pretty clean. And then what I'm doing is mainly just to get more experience with the electroplating equipment. I'm plating the copper onto there so we can reuse it. Now that's unnecessary, but mainly I'm doing it to get a little more familiarization with the equipment here and make sure things are working. And then we got a little over 13 grams of recovered silver, and we can then use for inquarting again. Overall, there should be very little loss, maybe 5 or 10% per cycle would be about the most I'd possibly expect. So that allows us to keep using the same silver over and over again to keep refining our gold beads to inquart and make sure we can weigh the gold accurately. So happy prospecting and keep it safe out there.